So in this class, we are going to solve A-levels paper variant 22 from the October-November 2025. Okay. So let's start with the first question. What they're telling us, scientists are investigating the variation in air pressure at different location on a mountain. The scientists take measurement of several physical quantities at each location. What we have to do, complete table 1.1 by stating the SI base unit of each quantity and identify with a tick mark whether it is scalar or vector. So what we have to do first, we have to write on the base unit. So first is very simple, but sure, it's air temperature. It is measured in Kelvin. Okay, make sure you don't write the Celsius. Okay, SI base unit is Kelvin. For pressure, you can drive this. We know pressure is force over area. For force, we have unit kg meter per second square. For area, we have units meter square. So you will end up with kg per meter per second square. So it is, we have to write down SI base units. Okay, and both quantities are scalar. Moving forward, second part B of it, at one location, the density of the air is given, it is 1.1. A spherical balloon is filled with the gas and released from a rest. It is spherical and the balloon has a radius of zero point 0.9. Calculate the upthrust acting on the balloon as it is released. So what we have to do, we have to calculate the upthrust force. For upthrust, we have a formula, F is equals to rho gv. Okay, and as we know it is spherical, so volume of sphere is 4 by 3 pi r cube. We have the r as well. Okay, so writing this is the density. We have 1.1 and g is 9.81 and v is 4 by 3 pi and r is 0.90. You have to take the cube of it. When you do the calculation, you will get 32.95. We will round it off to 2 SF, so it will 33. Second part, explain why an upthrust act on the balloon. Okay, why the upthrust force is acting basically where the balloon is. Okay, we don't have diagram. Let's suppose um, this is the air, what I'm making with this pink color, and this is representing a balloon. So when something is in the fluid, the depth at the top and the depth at the bottom, they have the different depths, right? So different depth mean they have different pressure. So at this point there is a low pressure. At this point there is a high pressure. Okay, so there is a high force and there is a less force. So this force difference will create a resultant upward force that is called, and it will create a resultant upthrust. Okay, so how we will answer this thing? So we can simply write it down. Because of difference in pressure of at top and bottom of balloon. Okay, so and you can mention that the force at bottom will be greater as compared to top. Okay, so that is the reason why we have upthrust. Moving forward, the balloon has a weight of 19 newtons. Calculate the magnitude of initial acceleration of the balloon. Okay, so what you have the weight. We know there are two forces acting on the balloon. One force is downward, that is the weight, 19 newton. And there is another force that we have calculated, that is upthrust force, right? So upthrust force is 33. So acceleration depends on resultant force, okay? So resultant force, we know from the second law, resultant force is equals to ma, and we know resultant force is 33 minus 19 is equals to m. We have to find from where we can calculate this thing. We have the weight of it, so we can calculate the m from there, right? So m will be equals to 19 divided by 9.81, so it can be 19 divided by 9.81 multiplied by a. So when you rearrange this thing, this will be uh, 33 minus 19 will give you 14, and when this thing will go on those side, it will be 81 divided by 19. You will get 7.2 meter per second square. Okay, moving forward, a quantity c relating to the motion of the balloon is calculated from the three measured quantities k, f, v using the formula they have shown. The percentage uncertainty in the measured quantities are given in the table. You have to calculate the uncertainty in C. Oh, the calculated value of C is 1.8. Determine the absolute uncertainty in C. Okay, so we have the relations. Let's write it down on the left side. C is equals to 2kf over v square. Okay, what you can do, you can simply ignore this thing 2. Okay, so what we have to, if you see k, f and v, they are multiplied and divided, so we have to use the rule of that thing. When the physical quantities are multiplied and divided, the percentage or the fractional uncertainties can be added. Okay, so first we can find the percentage. So percentage uncertainty of c will be equals to percentage uncertainty of k plus percentage uncertainty of f, plus there comes a 2 multiply y, because there's a square on the velocity. Okay, so this will be percentage uncertainty of v. Okay, let's write it down. You have all the values. K is 5 plus f uncertainty is 3 plus 2 multiplied by the v uncertainty is 4. So you will get, adding all of them, this will be 8 and 8, it will be 16%. Okay, so the uncertainty is 16%. What you have to find, you have to find absolute uncertainty, and you have the actual value as well. Okay, we know percentage uncertainty is basically delta c over c multiplied by 100, right? That is the formula for the percentage uncertainty, and that we are getting 16. So you can find delta c will be equals to 16 divided by 100 multiplied with the value of c, that is 1.8. That is also given. Okay, this is c. So doing the calculation, you will get 0.28. You will get 0.288, and we have to round it off to 1 SF, it will be 0.3. Okay, moving forward, question 2. A spacecraft in deep space uses jets of hot gas from its thrust to change its velocity, as shown in figure 2.1. This is the figure 2.1, shows a side view of the spacecraft at some of the its thrust. Okay, so there are the thrust C, thrust A, and thrust B. Thrust A is a distance of 1.6 meter leftward from the center of gravity. Okay, thrust C is a distance of 0.4 upward. Thrust C is 0. This is the center of gravity. Okay, so thrust A is distance of 1.6 from the center of gravity, and this is 0.4. Okay, thrust A and B are can produce forces on the spacecraft in the upward direction only. Thrust C can produce a force on the spacecraft in the leftward direction only. This will produce a force on the left. So let's note it down. This will produce a force in the leftward direction. Okay, let's call this FC. This can produce a force in the upward direction. Let's call this FA. And thrust, okay, this can also produce a force in the upward direction, that is FB. Okay, so that is the information given to us. All the upthrust shown produces forces entirely in the same plane as of the center of gravity, but we have to find thrust A is activated, producing a force of 60 Newton. So this is producing force of 60 Newton. Okay, and the thrust C is also activated, producing a force of 220 Newton. So this is producing a force of 220 Newton in the leftward direction. Calculate the resultant movement due to these forces about the center of gravity. So about the center of gravity mean this is the pivot point. Okay, so let's work it out. If you see, the line of action of force is of FA is this. Okay, what you have to do, you have to imagine another parallel line to the FA, but it should pass to the pivot point. This is, so the force is 60 and the distance between these two lines is 1.6. So this thing will try to rotate this thing like in this direction. Okay, so this will be a clockwise movement. So I can say clockwise movement, let's solve it there. Clockwise movement will be equals to 60 into 1.6. And when we deal with the anti-clockwise movement, if you see closely, the force is in this direction. Okay, and line of action of force, another line that is parallel to the force, is that should pass through the pivot point is this. You need a distance between them, that is 0 0.4, and this thing will produce a movement like this, that is anti-clockwise. So anti-clockwise movement will be equals to 220 into 0.40. Okay, so we have to calculate the resultant movement. So let's calculate which movement is greater. So it will be 60 into 1.6, it will give me 88, and 220 into 0.4 give me 96. So anti-clockwise movement is greater, so anti-clockwise movement minus clockwise movement is 96. My pen is not working. What we have to do, we have to calculate the difference between them. It will be 96 minus 88, that will give you 8 Newton, and its direction will be clockwise. So this is 8 Newton. Okay, you don't have to write down the direction, they have not asked. Okay, in the second part, they're asking state and explain whether the forces from A and C are couple. So for couple, we have different conditions. The forces should be equal. They should be in opposite direction. Okay, so none of the condition is satisfied here. So first thing you have to write down no. Then you have to explain they don't have equal magnitude. Equal magnitude. Okay. Moving forward, question part B. Thruster A and C are now switched off and the spacecraft is stationary. Okay. Thruster B is activated at time t1, producing a constant force on the spacecraft until the fuel runs out at a time t2. Okay. As the fuel is used, the total mass of the spacecraft decreases. Sketch the variation of the speed. Okay, so what we have to do, if you see at a time t1, A and B, when they are switched off, the spacecraft is stationary. So our graph will start from this point. Okay, at zero speed. And as you know, what is happening, the force is constant, the upward force is is producing a constant force, and what we have, the mass is decreasing. So as we know from the Newton's second law, if force is constant, acceleration will be inversely proportional with mass. If mass decrease, acceleration will increase. So we the slope is showing the acceleration in this graph. So this should be increasing slope. Okay, so it will be like this. Okay, moving forward to the part C. The spacecraft now split apart into a carrier and a payload. Okay, there are two parts. This is the payload, this is the carrier. During the split, an average force of 5500 Newton act on the payload for a time of this. The velocity of the payload increased by, so this is what you have. We have F, we have T, we have delta V. The combined mass of the carrier and this, we have state the principle of conservation of momentum. Okay, so what the principle of conservation of momentum is, uh, total momentum before and after collision should be conserved for an isolated system. Okay, one mark is for the conservation part and one mark is for this isolation part. Okay, next show that the mass of the payload is 230. Okay, you have to show the mass of the payload. So how we can calculate it? We have the data above. So we can do, we know from the impulse relation that delta p is equals to f into t. Okay, or you, the basic relation is f is delta p over t. Okay, so you can say, and delta p is basically mass into delta v, that is equals to f into t. So the mass will be f into t divided by delta v. We have all the information. Force is 5500, time is 0.36, and change in velocity is 8.5. You do the calculation, you will get 232.94. When you round it off to 2SF, it will be 230 kg. Moving forward, third part, calculate the magnitude of the change in velocity of the carrier. Okay, now you just have to calculate for the carrier. So what we can do, magnitude change, we know the change in momentum that we already calculated, have not calculated, but we know we have the values. It is equals to f into t. So that is basically 5500 into 0.36. Achha, this thing is for the carrier now. Okay, this change in momentum and force and time, all the things. So when you open this thing, this will be m into delta v. Now this mass is also for the carrier. Okay, so what I can write, I have to find change in velocity. So change in velocity is 5500 into 0.36 divided by mass of the carrier. We know the total mass of whole thing is 10 power 3, and we have calculated the mass of just the payload, that is 230. When you minus this thing, you will get the mass of carrier. So this is, you can, I can put this thing here, 2.5 10 is to power 3 minus 230, that will give me 0.87. Moving forward, question 3. A spring A spring is fixed at one end and attached to the frame of a pulley at the other end. Okay, this is the spring, and it is end. There is a pulley, and this is the fixed end. A cable is passed around the wheel of the pulley. Okay, this is the cable that is passing around the pulley. The spring is stretched to fixed length using the cable and the pulley. Okay, this is the length. Shows the view from above of the spring, cable, and the pulley. The spring obey Hooke's law and has a spring constant of K that is given to you 250. A force F act on the spring. The tension in the cable is T. Okay, and a pulley is in equilibrium. Draw the label arrows to show the direction of forces acting on the pulley. Okay, so as we have to draw it here, but just for the understanding, if these are the ropes, right, so they will have the tension here, and this is the force F that is applied here. Okay, F, sorry. So what we can draw, we can, the force F will be here, that is provided by the spring, and these are the two ropes attached here, they will provide the tension. You have to label it T. Moving forward, the force is 110 Newton. You have to find T. We know that thing is in equilibrium. So for equilibrium, sum of leftward forces, that is F, should be equal to sum of rightward forces, that is T plus T. So F is, we know it is 110, it's given here, is equals to 2T. So T is equals to 55. So this is 55 newtons. Moving forward, they're asking calculate the extension of the spring. So using the basic relation of the Hooke's law, F is equals to Kx. So X is equals to F over K. We know the force is 110 and K is also given above, that is 250. You will get 0.44 meter. In the next part, they are saying a second identical spring with the same spring constant is now also connected to the pulley, and if you see, it is connected parallel. Okay, the tension in the cable is kept the same. The pulley is again in equilibrium. Determine the extension of the spring. Okay, now the new spring, or you can say the combined spring constant for parallel will be K, that will be equals to 250 plus 250. It will be simply added up. So that will be 500. Okay, that is the spring constant. So if you have to find extension, we know F is equals to K into X is F over K. F was 110 and K is 500. So 110 divided by 500, that will give you 0.22. Okay, or you can solve it in that way as well. When there are two springs, what will happen? This is the alternative way. Okay, second method. When there are two springs, total force was 110. Half of the force will be go there, that is 55 Newton, and half of the force will be gone there. So force will be divided. So in that case, you can write as X is equals to F over K. So F will be taken as 55 and K will be taken as same. Okay, you're not dealing it collectively, but you are solving it individually, and we know the extension will be same in both the springs. Okay, so this thing will also give you 0.22. Next, the elastic potential energy stored in the spring is E1. The total elastic potential energy stored in two springs is E2. Calculate E1 over E2. Okay, so what is the relation for the elastic potential energy? E1 will be equals to 1 by 2 F into K, sorry, F into X. Okay, so when dealing with the first part, we know 1 by 2 F was 110 and extension was what was the extension? 0.44. I'm sticking with this method. Okay, so E2 will be 1 by 2 F into X. Force is same in that case as well, that is 110, but extension is 0.22 now. Okay, So what we have to do, we have to find the ratio. So E1 over E2, we have to divide them. When you divide, this thing will cancel, this thing will cancel, and this cancel will give you 2. So E1 over E2 will left with 2. So answer is 2. Okay. So you can say ratio is 2 ratio 1. Okay. There is 1. Next is a laser emit visible light of single frequency in a vacuum. The light is incident normally on a double slit and then forms a pattern of bright and dark fringes. Okay, so this is from the double slit topic. What we have the separation of the slit. Separation of the slit, if you remember, it is represented by A. This is the A. The distance from the slit to the screen is for this is represented by D. Here we are. The distance between the center of the this is represented by X. Okay, so this thing is X. Explain how the pattern of bright and dark fringes are formed. So you have to explain how this thing is happening. So when the light is go from there, the light will diffract and they will superimpose, and where the path difference is multiple of lambda, there will be a constructive. Let's write it down. So light pass through slit will be diffracted and superposition with each other. Okay. When two lights meet on screen, where path difference is n lambda, gives you constructive interference, or I should say it should give you what they were asking, bright and dark. Bright fringe and where path difference is n plus half lambda, we have dark fringe. Okay, so there we go. And the next part, calculate the frequency of the light emitted by the laser. Okay, so the basic relation for the double slit experiment was lambda is equals to a x over d. We have all the things. We have a, that is 1.0 10 raised to power minus 3. We have x, that is 3.3 milli 10 power minus 3. We have d, that is 4.8. Doing the calculation, you will get 6.875 10 raised to power minus 7. So this is the lambda. So using the wave equation, we know v is equals to f lambda. So f is equals to v by lambda, and we know the speed of light is constant, that is 3 into 10 raised to power 8 meter per second, divided by the value of this lambda. This is 6.875 into 10 raised to power minus 7. That will give us 4.4 into 10 raised to power 14. So our final answer is 4.4 into 10 raised to power 14 that we get. Why they are not patterns like this? Because we have the condition that the rays should be monochromatic or they should be coherent. So because they are not monochromatic, so we do not have any bright and dark fringes, or you can say they are not coherent. Okay, let's move forward to the question number 5. Shows a circuit containing a battery, two fixed resistors X and Y, and there is one LDR, that is this C. The battery has EMF of 5 watts. There we have an internal resistance of 4.7. There we have The current in X is I1 and in Y is I2. Okay. The resistance of the wire is 100 ohms and Z varies with the intensity of the light. Okay. And this is the graph given for the Z resistance. Okay. For the LDR. First, we have to state what is Kirchhoff rule. So Kirchhoff rule is simply, it's the algebraic sum of current at a junction should be zero. Okay. Moving forward, the intensity of Z is 130. The current in the battery is 38 milliampere. Show that the terminal potential difference is 4.8. Okay. So we have the intensity 130 for the Z. So 130 intensity will be, this is, if I have to look for the 130, two lines are showing this is 110. Okay, this is 120, this is 130. Okay, so 130 is here and this line is going right there. So this reading is 120 ohms. So resistance of the ohm of this thing is 120 and the current from the battery that is coming is given, that is 38 milliampere. That is the current that we have, total current. Okay, what we have to find, we have to find the potential of the cell. We have to find this thing. Okay, what we know, I know this is the total EMF provided and some of this EMF is wasted here in the internal resistance. So whatever is left will be given at the output. Okay, so I can say potential across cell is equals to EMF minus potential difference lost in internal resistance. So this is 5 and this thing is, the current is 3.8 is going there, it's mean 3.8 is coming here. So this thing is I into R. So this is 38 milli 10 power minus 3 and R is 4.7. That thing will give you the answer. Okay, let's paste this thing there in the section. This was the question. So we have, when we do the calculation, what we get, it is 4.8 that we have to prove. Okay, watts. Moving forward, we have to calculate the I2. Okay, so now look at what the I2 is. Let's move to the graph. We have to find this thing. What we know total current is equals to sum of I1 and I2, because this current is coming from here, that is 38. Some of it will go there and some of it will go there. So 38 milli 10 power minus 3 is equals to I1 and I2. So what I can write, I have to find I2. So I2 can be written as I minus I1. So I, we know it is 38 milli 10 power minus 3. What is I1? I1, how I can find? From the Ohm's law, we know V is equals to, I is equals to V by R. Okay, and we know what the potential is here. The same potential will be at this point. Okay, so it was 4.8 that we have calculated, and R is the total resistance, 100 plus 120. Okay, so this is the current that is in, this is I1 basically. So this is V1 and this is the whole X plus XC. So this thing will be going to be pasted here, 4.8 divided by 100 plus 120, and let's move this thing to the right section. Sorry, I'm going to paste this thing there. Okay, so when we do the calculation, what we get, we will get, this was 0.016 amp. Okay, so this is the answer. Moving forward, you have to calculate the power dissipated in Y. You simply have to use the formula P is equals to V into I. So what is the voltage across Y? That you have to look into. Let's go back where the Y was. This is the Y. So Y have the same voltage that this thing is providing, that is 4.8, and current I2 we just have find, so it is 4.8 into 4.8 into 0.016, so that will give you 0.077 watts. In fourth part, the intensity of the light incident on the Z decreases. State and explain the effect on the terminal potential difference of the battery. Okay, so let's move to the diagram again. Okay, so let me copy this diagram there so we can discuss it properly how we are doing this. So let's move to the part so I can write it down side by side and we can refer to the diagram as well. Allow pasting, there we go. Okay, so this is the diagram that we are talking about. Okay, and it's 3-mark question that we have to answer. The light intensity is decreasing, so light intensity decrease, so I can say that from R of Z increase, right? We know they are inversely proportional. When the intensity decrease, light intensity, the resistance increase. So when the resistance is increasing, this resistance is increasing, I can say that this total resistance that is here, that is, you can say R xz, that also increase because it is a sum of Rx and Rz, right? So when this thing increase, I can say the total current I total will decrease. Remember, from the Kirchhoff rule we have selected this loop and we can find the I, right? So the current in that part will decrease, so the total current will also decrease. Okay, so when the current is decreasing, what will happen? This potential difference of 4.7, remember its potential is 4.7 into the I, and we know this I is decreasing. So when this I decrease, this whole thing will also decrease. So when this whole thing is decreasing, we know this potential difference that is coming from the cell, it was 5 minus I into this R. This thing will decrease, so a smaller number will be subtracted from this 5, so this will increase this potential difference. Okay, I hope you understand this now. Let's write it down. If you have difficulty understanding this, you can go back into the video and you can rewatch this thing and try to make the sequence side by side by watching the circuit. Okay, so what we can write, resistance of LDR increases because light is decreasing, increases that increase the total resistance of loop, I should say, current coming out of battery, I should say current passing through battery will decrease that that decrease the voltages or the potential difference lost in internal resistance that result into increase in terminal potential difference across battery. Okay, let's move forward. Question 6. State what is meant by the fundamental particles. Okay, what the fundamental particles are, we can say they cannot be subdivided. Okay, they are the smallest possible particles. Okay, in part B, particle Q is a meson with a charge of 0. Determine a possible quark composition for Q. We know in the meson they are made up of one quark and an antiquark. So what we can say, it's a 2-mark question. So any combination with one quark and antiquark. Okay, this can lead to us. So what you can do, you can write up and anti up. You can say down and anti down. Okay, so any combination with it. And the second part, particle Q has a mass of this 0.67 u and kinetic energy of this. You have to find speed. You have to use the kinetic energy formula. Kinetic energy is half mv square. So v square is equals to 2 into kinetic energy divided by m. You have to take the square root on both sides. So it will be under root 2 ke divided by m. If you see the units, the answer is in meter per second. So you have to change your mass. So changing 0, this is 0.67 u. You have to change into kg. 0.67 into, you have to multiply with 1.66 10 raised to power minus 27 kg. So putting this value here, 2 into kinetic energy is 2.1, 10 raised to power 6, it is given there. Okay, divided by the mass, that is 0.67 into 1.66 into 10 raised to power minus 27. That leads to 6.1 10 raised to power 5. Okay, so this is the speed. Moving forward, radium-228 is a radioactive nuclide. State the number of electrons in a neutral atom of 2. So these are the number of protons. It will have the same number of electrons as well. So it is 88. In the next part, a nucleus of radium-228 undergoes a series of decay to form a X. During the process, 5 alpha and 4 beta particles are emitted. Determine the number of protons and neutrons in this. Okay, one way is that you can do the 5 different decays for the alpha and 4 different decays for the beta. Okay, and then you can get the number of neutron and proton. Or there's another direct method that you can do. As I know, radon is Ra228 88. It's going to decay with 5 alphas. I know alpha is 42. It is going to decay with 4 betas, and beta is 0 minus 1. Okay, I'm going to use the balancing of equation, and what is left will be, this will be A, X will be AC. I can use the balancing of equation method. First I'm going to balance the masses. Okay, so when I balance the masses, it will be 228 is equals to 54 plus 4 into 0 plus A. So A will be 228 minus 54. This thing will give me 20. 8. Okay, now I'm going to balance the charges. Okay, so it will be 88 is equals to 2 plus 4 into minus 1 plus z. So z is 88 minus 2 plus 4. So that thing will be, sorry, I have done a mistake here. What is, okay, there is mistake. This is, oh sorry, this is basically 5. Let me write up this thing clearly. This is alpha, this is 5, this is 4, and this is 2. So this thing should be 5 into 4, this thing should be 20, and this thing should be 20 plus, sorry, let me do it again. So a will be equals to 228 minus 20, that will give you 208. Okay, and there this thing will be, let me write down again. It will be 88 is equals to 5 into 2 plus 4 into minus 1 plus z. Okay, so z is 88 minus 10 plus 4. So this will be 82. Okay, so how many protons you have? You have 82 protons. You have to find neutrons. So neutrons will be a minus z, that is 208 minus 82, that will give you 126. Okay, so that's it.